we need to take a look at the big picture. The whole chapter, chapter 6, is all about systems of equations. Now what that means is we're going to be looking at more than one equation at a time. So in a graph, you're going to have two lines on a graph, and that's what we're going to be dealing with today. What does that look like in graph form? Okay, so we have number one, it says name the three possible situations when you have two lines. If we graph two lines on a number line, there's three things that could happen. Not a number line, coordinate graph. So here's your coordinate graph. We could have two lines that intersect at exactly one point, right? We could have two lines that are parallel that never touch, right? And the last one is probably something you don't even think about, but it could be two lines that are the exact same line. So you don't even think of them as being two lines, but there's two lines there. Like if you had a graph two, it looked like they were in two different formats. One was in standard form, the other one was in slope-intercept form, and you graphed them on the same graph. It ended up being the same line. Now, if you look at, okay, so the type of lines shown here are called what? What are these called? Parallel. Okay. These lines have how many intersections? How many times? Zero. Okay. So guess what? I said the number of intersections, but the problem actually says the number of solutions. Because in a system of equations, when you're graphing, the solution to this is the place of intersection. So intersection is the solution. So parallel lines don't have any solutions. They don't have any point in common. That would be the solution. What do we know about the slopes of parallel lines? They're the same. They're equal. That's a bonus from a couple chapters ago. All right, let me write down the people that have joined us here. So I have Kai came in, and I have Ava came in. I better just double check who I've got. Grady's in, I forgot to add him in here. Addison is in person. Brady's in person. Cooper. Evan's not here. Braden. Okay. All right, we're good. All right, now the type of lines that are shown down here, what kind of lines are they? Intersecting. So how many solutions do they have? One. Right here. That's the solution to that system. The slopes of these lines are
opposite?
Well, not necessarily opposite. They're just not the same, right? So they're not equal. All right, now this last one is the weird one. See how it's a really, really thick line? That's because it's like two lines that are the same line. So these would be called identical lines. how many solutions do they have in common? How many points of intersection?
Infinity?
Yes. They have an infinite number of solutions. And the slopes of these lines are also the same. Okay, so that are 3 types of solution or systems that we're going to be talking about in the next couple of days. Okay, so if we go to the next page, it says draw an example different from the one in the front of intersecting lines. So just draw a set of lines that are intersecting. 2 lines that intersect. Just draw it. Do you need notes?
I think so.
Okay. You gotta speak up. I got plenty of them right here. There you go. All right, so I don't know, I could do this. There it is. I could do anything as long as they touch in one spot. Draw an example different from the one in the front of same lines. So identical lines. If I were able to do 2 different colors, I would do 2 different colors. Now I know I can change the color, but it'll actually change the color of everything I've done already, so it wouldn't make any difference. So I might do that. And then it says draw an example different from the one in the front of parallel lines. Parallel lines. Oh, my parallel's really bad. Okay. Is it possible for 2 lines to intersect in exactly 2 places? Let's try it.
Yes.
There's a line. Can I get another line to go through it and cross it in 2 places? I could get an arc to cross it, but not a line. The line has to be straight, right? So that would be a no. Can't do it.
Does it mean just 2 places, or does it mean like could it?
It says exactly 2 places.
Oh, okay, never mind.
Exactly was the key word there. What type of lines produce the most solutions? Same lines or identical. What form must a line be written in before it can be entered into the graphing calculator? You guys haven't done anything with the graph. What's that? Nope. What's the way we like to graph it the most?
Slope-intercept form?
Slope-intercept form. You guys might know it. If you don't remember the word slope-intercept, I should spell it right, is y equals mx plus b. So if you have it in this format, you can graph it in the graphing calculator. By the way, I'm kind of contemplating that section might be our next chapter, is an outside of the book graphing calculator chapter, okay? So you're going to learn how to do some of these things on a graphing calculator. All right, so we're on page 3 of your notes. We're flying through it, huh? So the first problem, we have a graph below. I love reading graphs. Do you know what this helps you with? Your science MCAs. Because your science MCAs is going to be filled with charts and graphs, and you have to be able to interpret the data. It also makes sense with math. So here's the deal. Let's read the title. It says the height of 2 trees. The x-axis says the age in years. So we have 0, 1, 2, 3, 4, 5, 6, 7. So we're going from 0 years to 10 years. The y values are the height in inches. So we have 2 lines. That means we have 2 different trees. Now it's kind of hard to read because the quality of the letters and images aren't so hot, but the solid line stands for a redwood tree. And this dashed line stands for an oak tree. So this right here is the oak. And this right here is the redwood. So it says, which tree was taller when it was planted? Well, when it was planted would correspond with what year? 0. So we look at 0 and we have the oak is here and the redwood is here. So which one was taller? The redwood. At what year are the trees the same height? At year 6. How tall were they at that point? 50 inches. It didn't ask that, but if it did, that's our coordinate of our solution of where the 2 trees were the same height. Which tree is growing faster? How do you know? Right, which means it has a
Steeper slope.
Steeper slope, right. About how tall is the redwood at age 11? Okay, so it's off the chart, kind of going up. What do you think it is?
58. Because the slope would be 110.6. So by the time it hit 12, it would be 60, and then you.
Yeah, but it's 11. It asked for 11 instead of 12.
Yeah, but if you. Never mind. You probably got a different way of finding it.
Hold on a second here. See that? That word about means that if you're in the ballpark, you would get the right answer. About how tall is the redwood? Some here said 55, you said 58. I would have accepted both of them because it's like an approximation. Okay, about how tall is the oak at age 11? 71-ish, 72, somewhere around in the early 70s. Okay, now it says, does that make sense how to read that interpret the graph and what's going on? The big thing that we're talking about here is our intersection. That intersection is what we're looking for, okay? That's what we're going to be stressing the rest of today. So if you look at example 2, it has a graph of 2 lines. We're supposed to choose which one of these systems is represents those lines. So let's start with this line. This will be line 1. This will be line 2. Let's go from the graph. Line 1 has a y-intercept of what? 3. So if we do y equals mx plus b, the b is 3. Now if we follow it along, it kind of looks like it's there, but it's not perfect. All right, so what's the slope? -1/3. So this would be my first equation. Is there anything over here that has a y equals -1/3 x plus 3? Which one? Just D. Okay, so I don't even have to do the other one. If more than one had that equation, then I'd have to go down here to graph 2 and I'd have to figure that one out. So I would look here and say, oh, look, it crosses at -1/2. let's go from here to here. So that would be a 1/2 slope. So my equation would be y equals 1/2 x minus 1/2. Now, I'm going to tell you right now that your assignment today is not going to be going from this direction using the graphs to find the equations. You're going to be starting with the equations and have to graph it and find the point of intersection. So let's do a couple of these though, and then we'll get started on our actual homework. Okay, so we have another real world situation, another interpreting a graph. It says, look at the graph below about money in the bank. I like money in the bank. I wish I had some money in the bank, but I like it if it was there. All right, now the X value said years since account was opened. And the Y value says how many dollars are in the bank. And we've got two different accounts, right? We've got the solid line account. Let's call that the $700 account, because that's where it started, right? And the, almost $200 account, or a little over $200 account. So those can be our two accounts. After how many years were the accounts equal? Yep, 5 years. You follow them along, you find out where their point of intersection is, and then you follow that down here and you say, oh, yep, that's at 5. How much did the account start with? All right, we already called them that, right? $700 and approximately 200. It's a little over, but we'll just go with that. Which account has more after 3 years? The $700 account has more after 3 years. Which account has more in it after 8 years? How did that happen? How did the $200 account jump past? It has a steeper slope, but in real life, I'm thinking in real life, how can my two accounts, one only goes up at a slower rate than the other? Yeah, it's getting more interest probably. Or if I keep adding to the account every year, I might be adding more in the smaller account. I'm going to skip number 4. And I think we did that one. So, okay, here's what I want you to do. I want you to pull up the worksheet for today. And I am going to go ahead and pull it up as well. It is in Schoology. Okay. And this is, where'd it go? There we go. This is what it looks like. Okay, so for how many problems?
10.
10 problems, that's it. That's all you have to do. We're going to solve it by graphing. Now, what do I mean by solve? What do I mean by solve? How do I solve this problem?
You plot the equations on the graph and then find the point of intersection, or if there is any.
There you go. That's the key. The point of intersection is our solution. Okay. So we're going to do number 1 together. All right, so I'm going to graph, and I'm going to do it in different colors because I can on this one. Okay, so I'm going to graph this one in, apparently it's like a burgundy. So I'm going to start with my y-intercept. So I've got a y-intercept of -4. So I start there. Then I have a slope of 3 over 1. So I go up 3 and over 1. Up 3 and over 1. Up 3 and over 1. All right. So then I connect the dots. Ooh, and this is going to get ugly. Oh, ouch. Okay, that was bad. Okay, I'm going to cheat. I'm going to use my line. Okay, much better. Better than what I can do. Okay, now I'll do blue for this line. So I'm going to go up 2. From there, I'm going to go down 3 and over 1. 1, 2, 3 and over 1. 1, 2, 3 and over 1. And now I'm going to grab this one. No, I don't want the arrow on it. Okay, now I graphed them, but I'm not done with this problem because I need to name my solution. What is the actual solution to this problem? 1, -1. This point right here, that's my solution. All right, that is your job for today.
What if it doesn't fit on the graph?
What's that?
What if it doesn't fit on the graph?
It should.
The second one. It says 4, 3. Start at 3.
Oh, you can do a -, and go down and left, if that helps. Does this make sense to everybody at home? So we're looking for that point of intersection. That's what our job is today, is to find out where those 2 lines meet. If they're parallel and they don't meet, then you would write no solution. If they're the exact same line, then you would write infinite solutions. And if you want to not have to write the word infinite out because it's, you know, your wrist hurts from writing so much, you can use the sideways 8 for infinite. Okay. Do you guys have any questions for me? This is our jumping into chapter 6. It's not too bad, is it? Good. All right. So those of you who are at home, if you want to check off, leave the Zoom and start working on this and get it done for tomorrow, we're going to grade it. And I will see you tomorrow. I do have a Zoom session open at from 3 to 3:30 today. And by the way, I think I'm going to change my Zoom after school Zooms on Wednesdays from 2 to 2:30, so that if there's anybody that's involved in sports, then you would still have time to get to your activities if you needed to get in and get some help with any questions you have. Does that make sense? All right. Any questions before you leave?
Have a nice day.
Thank you. You too.